9.3 ellipses. Here we go. An ellipse is our second conic section. If you slice a cone at an angle, if you slice it straight across, you produce a circle. If you slice it at an angle, you produce an ellipse. This is why these are called conic sections, because they come from slicing up a 3D cone. All right, so a couple questions and answers about ellipses. Question number 1. What is it about this equation that says I am an ellipse? And answer 1, the coefficient of x squared and the coefficient of y squared have the same sign but different value. Okay, if they're the exact same value, sign and all, that's a circle. If they are same sign, different value, that's an ellipse. And it's kind of just like we're distorting it in one direction or the other, which is what an ellipse is. It's sort of like a circle, but we've distorted it one way or the other. When we get to the next section, hyperbolas, that's when one of these is going to be negative, but we'll worry about that later. So question 1, how do you know it's an ellipse? Because those two numbers are both positive but not the same. Question 2, geometrically speaking, what's the definition of an ellipse? Okay, last time the definition of a circle is all points equidistant from one point. So that's how we had the center, and then the radius was that distance. An ellipse, this time take 2 points, called the focal points, or foci. That's the plural of focus. All points that are the same combined distance from those 2 points form an ellipse. So let's just say that, for example, that distance is 10. If you were to have a string, and we can do this in class, if you had a string tied between those 2 dots and you pulled it tight, for instance, you took your pencil and you held that string and you pulled it to where it was tight, like that, and then you traced all the way around, keeping that string tight, those would be all the points on an ellipse. And this is very hard to describe without showing it. That's why we'll do it in class. But let's just say that that distance were 10. You might have 5 and 5 like that. You might have 4 and 6 like that. You might have 2 and 8 like that. All the way over to here to maybe 1 and 9. But if you did that for all possibilities, you end up tracing out a nice squished circle. It's called an ellipse. And the demonstration will help a lot on that. So what you need to know right now is, this is page 473 in your book, by the way. An ellipse is a set of points in a plane. For each point, the sum of its distances, d1 plus d2, from 2 fixed points, f1 and f2, is constant. So with a circle, it was just 1 point. We always had the same distance from that 1 point. But now we've got 2 reference points. Wherever I go, that distance plus that distance has to add up to 10 in this case. Okay, so there's question 1 and question 2. Here comes question 3. If I give you this ellipse, how do you graph it? How do you get more information about it? And that's by putting it into standard form. So, what does standard form look like? Standard form of an ellipse looks like this. X minus h over r sub x squared plus y minus k over r sub y squared equals 1. Now there's some similarities to standard form of a circle in there, but there's definitely some differences as well. So let's take that same equation from earlier and put it down here. and we need to work on getting this equation into that form. You notice there's some completed squares in this general form. The major difference is that this one equals 1 on the right, whereas in the circle equation, it equaled the radius squared on the right. Don't confuse those two. It happens a lot, but you don't want to let that happen. So what we need to do is try to make this look like that. Okay, so step 1. What I want to do in step 1 is get my x stuff together. And get my y stuff together. And also I'm going to go ahead and take that 164 and move it on over to the right. Eventually that right side will equal 1, but for now just get all the constants over. Next, when you complete a square, you need just one x squared and one y squared. There can be no coefficients of x squared when you complete the square. So I'm going to factor out 25 from those first two terms. And also, I'm going to leave the blank where I'm going to complete the square. All right, this leaving the blank is nothing new. We've done this. But factoring out is kind of new. So I'm going to factor a 9 out of the next two terms, get y squared minus 4y. And I'm also going to leave that blank right there. Okay, so in the first line, I did two things. I grouped my x's and I grouped my y's, and I moved the 164 to the other side. My second line, I'm going to do two things. I'm going to factor out the coefficient of x squared and y squared, and I'm going to leave a space for my next number that goes in there. Okay, so to complete the square, you take half of the middle term and square it. So half of 2 is 1. 1 squared is 1. Now, I did not increase the left side of my equation by 1. I increased the left side of my equation by 25 times 1. Right? Because that 25 applies to everything in the parentheses. So if I'm going to add 25 to the left, I need to add 25 to the right. Okay? So see if you can guess what's going to go in this next blank. All right? Half of negative 4 is negative 2. Square that and you get 4. Now I'm not going to add 4 to the other side. I'm going to add 36 to the other side. Most of the equations in the book work out nice and neat the way this one does. They don't always. We'll do some that don't, but don't worry about that if it happens. We just work with fractions and decimals. It's no big deal. All right, so now I'm getting pretty close to being able to write it into the proper form. My completed square is x plus 1 quantity squared, and my y clump is y minus 2 quantity squared. That's why I put the 1 and the 4 in there, so I could write it as a completed square. And then 164 and 25 and 36 adds up to 5, 2, 2, 225. All right, nice, convenient numbers still. A lot of perfect squares, I see. Now, remember, I need a 1 on the right-hand side. So to get that 1, I'm going to divide everything by 225. As long as every term gets divided, that's legitimate. So that gives me the 1 on the right. Now, to make the left two, the little x clump and the y clump, look like they should, I'm going to do a couple things. First of all, I'm going to simplify 25 over 225. All right, how many times does 25 go into 225? That's 9 times. So instead of writing 25 225ths, I'm going to think of that as 1/9, because that. So I'm just going to simplify that fraction and make it 1/9 instead of 25 225ths. 9 then can be expressed as 9 out of 225 is the same as 1 out of 25. All right, makes sense, just simplifying fractions. Okay, and then this side equals 1. All right, now it almost looks just right. I'll accept this r sub x and r sub y are within the parentheses being squared. So your last step is to take that 9 and put it into the parentheses and make it a 3. The 25 goes into the parentheses and it becomes a 5. So this is the standard form of this equation. I haven't changed it. I haven't changed the shape of it. I've just changed the way it looks, just like we did with circles. So here are the parts. The center is found just like the center of a circle is found. Whatever goes with x, the opposite of that is the x coordinate, and the y, opposite of that is the y coordinate. So my center is negative 1, 2, because I was x plus 1 and y minus 2. Now, sub-question, does an ellipse have a radius? Well, sort of. An ellipse has two radii. It has an x radius and a y radius, because you know they're distorted. You don't go up and down the same amount that you go left and right. The number in the bottom of the x clump, that's the x radius. So for us, that's 3, and the y radius is 5. All right, so let's graph this thing. It's got a center of negative 1, 2, an x radius of 3, and a y radius of 5. Graph paper. Center is negative 1, 2. X radius 3. So I'm going to go left and right 3. Make little marks to mark those. And I'm going to go up and down 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, and then connect the dots in as smooth and as pretty of an ellipse as you can make. They won't all be great. That one's not real great. A lot of times they end up being more diamond shaped, but that's all right. Okay, so there we go. There is putting an ellipse into standard form and graphing it. There are a few more facts about ellipses that I'm going to show you, but we'll just go over those in class. So that'll be it. This is your video on graphing ellipses, and I will see you. Young out.